Hello, welcome back to Learn Physics. In today's topic, I am going to continue with work, energy and power. Okay, so in last video we did some of the textbook exercises, isn't it? Today I am continuing with the exercise questions, that is from page number 136, question number 9 onwards. Okay, so first one is ninth one. A body is initially at rest. It undergoes one-dimensional motion with constant acceleration. The power delivered to it at time t is proportional to. So the power is proportional to. The values are given t to the power half t. It's with respect to which power of t, that only we should find out. Okay, so the body is initially at rest. It undergoes one-dimensional motion with constant acceleration. So power delivered to it we should find out. Power, what is the formula? Work done divided by time. This is the formula for power. So to find out work done, what we should find out? F into S divided by T. So but we know S by T is V. So F into V. Okay, velocity. So but here we don't know what is velocity, but they are given it as initially at rest. The object was initially at rest and it undergoes one-dimensional motion with constant acceleration. That also given. Okay, so we can find out the final velocity V as V equals U plus AT. U is equal to 0, therefore V is equal to AT. So we can write it as P equals F into AT. What is A? A is equal to M. Yeah, F is equal to MA into T. MA into T, isn't it? So it is MA square T. So M is a constant and it is moving with a constant acceleration. So it is also a constant. So we can write it as P is proportional to T. So power will be proportional to first power of T. So the answer will be second one. Okay, so second one is the answer. Okay, so next one is 10th one. A body is moving unidirectionally under the influence of a source of constant power. Its displacement in time is proportional to. See, a body is moving unidirectionally under the influence of a source of constant power. So power is constant. And its displacement in time t is proportional to. So we should find out the displacement. How we can find out the displacement here? Displacement is proportional to which one? That only we need to find out, isn't it? So in terms of t only we should find out that. How we can find out this? P equals F into V. Here I am considering the dimensional quantities. While I am considering the dimension, so dimension of force is MA, LT to the power minus 2 into, what is the dimension of velocity? LT to the power minus 1. So we can write it as L square T to the power minus 3. So that is dimension of power. But we know that power is a constant, they told, isn't it? So M is also a constant, L square T to the power minus 3, that is equal to constant. Or we can write L square into T to the power minus 3 is a constant since M is a constant. Or we can write it as L square is equal to 1 by T to the power 3, so is proportional to. Okay, L square, L is proportional to 1 by T cube the whole power 1 by 2. That is L is proportional to 1 by T to the power 3 by 2. Or we can write it as displacement L is proportional to T to the power minus 3 by 2. Okay, clear? So T to the power minus 3 by 2. So the answer is, so here it is L square T to the power minus 3 t to the power minus 3 by 2, so it will become t to the power plus 3 by 2 here. Okay, because it is t to the power minus 3, right? So while we are considering here, it will become 1 by t to the power minus 3. So t to the power plus 3 by 2, it will be the answer. Okay, so the answer is third one. So now moving to the next question, that is, a body constrained to move along the z-axis of a coordinate system is subjected to a constant force given by F equals. So F is given as minus I plus 2j plus 3k Newton, where I, j and k are unit vectors along x, y and z axis of the system respectively. What is the work done by this force in moving the body at a distance of 4 meter along z axis? So the displacement is happening along this z axis. Z axis, how we will represent with the k? It is 4 meter. So it will be 4k. So we should find out the work done. Work done, how we can find out? Work done, W equals, work done is a scalar quantity, is equal to F dot S. So what is F? Minus I plus 2j plus 3k dot 4k. So it will be 4 3s are 12, because I dot k is 0, j dot k also 0, only k dot k will be existing, right? So 4 3s are 12 joules. Okay, clear? So the next one is, an electron and a proton are detected in a cosmic ray experiment, the first with kinetic energy 10 kilo electron volt and the second with 100 kilo electron volt. Which is faster, the electron or the proton? Obtain the ratio of their speeds. Electron mass, proton mass and 1 electron volt also given. So we should find out the which is fast. So what we can find out? Velocity of ratio of velocities we can find out. Okay, so we can understand which will be greater. Okay, so for that it is given as 12th one. The first with electron and proton are moving with the kinetic energy. First with so kinetic energy of first one is electron, isn't it? So is moving with velocity of 10 kilo electron volt and kinetic energy of proton is given as 100 kilo electron volt. Okay, how we can find out which is fast? Obtain their ratio of their speeds. So half mass of electron into velocity of electron divided by half into mass of proton into velocity of proton, the whole square. That is equal to 10 divided by 100 kilo electron volt. Both will be cancelling each other. So no need, if you are not converting also, 1.6 into 10 to the power minus 19 you should multiply to convert kilo electron volt to volt. Okay, so that will anyway it will cancel. So this half and half also will get cancelled. So VE by VP square, that is equal to 10 by 100 into mass of proton, it's given in the question, mass of electron. Then take the ratio. And so while we are finding out the mass of electron, it is 10 into mass of proton is given as 1.6 into 10 to the power minus 27 and 100 into mass of electron is, we know, 9.1 into 10 to the power minus 31. So while we are solving this one, we will get it as, see, 1 by 10, it is almost 1.5 divided by 10, so 0.1 something you will get into, see, 10 to the power minus 26 and here it is minus 31. While it is going upward, it is a positive greater than 1. So which will be greater? Yes, VE will be greater than VP. So while we are considering VE by VP, 13.3 something we will get. Okay, this and all calculation, that one you can do, right? So VE by VP is greater than 1. If it is greater than 1, which is greater? VE is greater than VP. Like that we will get. Clear? So now the 13th one. A raindrop of radius 2 millimeter falls from a height of 500 meter above the ground. It falls with decreasing acceleration until at half its original height it attains its maximum speed and moves with uniform speed thereafter. What is the work done by the gravitational force on the drop in the first and second half of the journey? What is the work done by the resistive force in the entire journey if its speed on reaching the ground is 10 meter per second? So a raindrop of radius 2 millimeter. We can convert it into meter. 2 into 10 to the power minus 3 meter. Falls from a height 500 meter above the ground. Total height is 500 meter. It falls with a decreasing acceleration until at half of its original height it attains maximum speed. So when it reaches to the half of the height, so it is attaining a constant speed. Okay, so here what is the work done by the gravitational force on the drop in the first and second half of its journey? See, first we will find out the first half of the journey, that is till 250 meter. What is the work done? What is the formula to find out the work done? Work done equals force into displacement, isn't it? Displacement we know it is 250 meter. Force, what is the force done? Force, it is M into G into S. What is EM here? We don't know. We don't know the value of EM. Any other method is there to find out EM? Density equals mass by volume. So M will be equal to density into volume. Density of water 10 to the power 3 kilogram per meter cube into volume is 4 by 3 by R cube. Okay, so here 10 to the power 3 into 4 pi divided by 3 into R is 2 into 10 to the power minus 3 the whole cube. So we will get the answer for mass here. Now we can substitute the work done. W equals mg. M is this much. 10 to the power 3 into 4 into 22 by 7 divided by 3 into 8 into 10 to the power minus 9. Isn't it? Into G value is 10, we can consider 10 into S is 250. While you are doing this one, you will get the answer for work done. You will get it as 0.082 joule. Like that you will get the work done, and while calculating you will get the value like this. This is the work done for the first half. Then second half, what will be the work done? It is moving with a constant speed, isn't it? If it is moving with a constant speed, what will be the acceleration? Acceleration will be 0. Okay, only gravitational force will be there. Only gravitational force will be there. So the work done will remain the same. In the second half also the same work only will be doing, because the velocity is decreasing. Its acceleration is decreasing very little, or if it is moving with constant speed, it will be having the same work done. Work done will be same, it will be continuing. Okay, so then next is, what is the work done by the resistive force in the entire journey if its speed on reaching the ground is 10 meter per second? How we can find out what is the work done by the resistive force? Work done by the resistive force. How we can find out the air resistance? Because of air resistance and all, what will be the work done? How we can find out that one? Work done means it is equal to energy. As per work energy theorem, we already learned it as work done will be equal to energy. So at a particular height 500 meters, what will be the energy over there? It will be the potential energy. That will be equal to the kinetic energy when it is reaching at the ground. Isn't it? So at reaching the ground, the velocity is given as 10 meter per second. So velocity at the ground is 10 meter per second. At a particular height, it is Yes, mgh. So as per conservation, we know both the energies should be equal. If there is no, if they are not equal, the rest of the energy is lost by the resistive force. Oh, okay, so shall we do that? Now potential energy is equal to mgh. Mass already we are getting from here. So 10 to the power 3 into 4 by 3 pi into 8 into 10 to the power minus 9 into 9.8 into h is 500 meter. So you can calculate this one, 0.164 joule. This is potential energy. Now it is kinetic energy as half mv square. So again we are substituting the value of mass and velocity is given as 10 meter per second, 10 square. While we are calculating this, we will get it as 1.6 into 10 to the power minus 3 joule. So here you see this is 0.0016 only we will be getting, isn't it? But here it is 0.164. So while we are taking the difference between, so the work done due to resistive force will be loss in work done, that is 0.164 minus 1.6 into 10 to the power minus 3. While you are subtracting these two, you will get the value for work done by the resistive force. Clear how we will be finding out all those things? See, reading the question, if you are feeling it is difficult also, whatever the non-concept for you, you can apply that. Okay, it is easy to find out the answer. Please understand that. Okay, don't get fear about the numericals. Okay, so shall we move to the next one? A molecule in a gas container hits a horizontal wall with speed 200 meter per second and angle 30 degree with the normal and rebounds with the same speed. Is momentum conserved in the collision? Is the collision as elastic or inelastic? So a molecule in a gas container hits the horizontal wall. So this is 14th question, and this is the wall, and it is moving with respect to the normal. It is making an angle 30 degree and rebounds. So it's making a rebounding means same angle it is making. Okay, so if it is rebounding back, is the momentum conserved in the collision? But we know in elastic and inelastic collisions, momentum is a conserved quantity. Only kinetic energy will be changing, isn't it? So it's a conserved. Momentum will be conserved in elastic and inelastic collision. So here momentum is conserved. Okay, so now we will think about the kinetic energy. We can find out the kinetic energy before and after collision. If it is equal, we can say it is elastic collision. If it is unequal, we can say it is inelastic collision. So kinetic energy we are going to find out. First one, before collision. Before collision, what will be the kinetic energy? Half mv square. Okay, m half into m into what is the velocity? It's given, right? It's given as 200 meter per second. So it is 200 the whole square. Okay, so mass is given as mass of a molecule only it is given. Mass is not given, half mv square. So this will be. Now we are going to after collision. After collision, how we can find out? Half mv square plus it is colliding with what? It is colliding with the wall of the container. So what is the mass of the container? We don't know. I am taking it as capital M. What will be the velocity of the container, wall of the container? It's 0. It is at rest, right? So velocity is 0. So here also it will remain as half m into 200 the whole square. So it will be existing as, yes, 200 in both the cases, isn't it? So whether it is elastic, so same only, right? Here before collision also same and after collision also same. So it will be an elastic collision. Since kinetic energy remains the same, it will be an elastic collision. Clear? Now the 15th one. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? Okay, so here it's given as the pump volume of the tank is given as 30 meter cube. Okay, and it is doing in 15 minutes. So 15 into 60 seconds. Okay, and then if the tank is 40 meter above the ground, height is given as 40 meter. What we should find out, efficiency is given as 30%. How much electric power is consumed by the pump? The electric power consumed we should find out. That means consumed means it is used, isn't it? So that is the input power we should find out, isn't it? Efficiency equals output by input. Output means it will be filling the tank, isn't it? How much it will be, how much power is used to fill the tank. That power here will be equal to the output power, isn't it? So first we can find out the power which is used to fill the tank. Okay, so power will be equal to work done divided by time. Work done means we will be carrying water from ground to the height of 40 meter. So what will be the power? Potential energy, mgh by T. What is the mass here? Mass equals density into volume. Density equals mass by volume. So density 10 to the power 3, since it is water, volume is 30. So this will be the mass, 30 into 10 to the power 3 into approximately I am taking G value as 10 and H is given as 40 meter divided by 15 into 60. Okay, here 15 to this is 30. Okay, so it is 4 by 3 into 10 to the power 4. That is the output power. Now how we can find out the input eta equals PO by PI. So input power PI equals, what will be the input power? PO divided by eta. 4 by 3 into 10 to the power 4 into divided by 30%, 30 by 100. So we will get the answer as, we will get 43567 watt. Like that you can do the calculation and find out the final answer. So clear till this? So the answers are easy, right? This is easy to solve. Only 2-3 formulas we should remember and just understand that and find out the answers. Okay, so I am winding up for today. I hope all of you understood all those things. If you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.